Let's talk about systems of qualities, inequalities today. We've been, for the last 2 weeks, been studying systems of equations, and system inequalities are very similar. A system of inequalities is a set of two or more inequalities with the same variables. And if you remember, that's pretty much the same definition for a system of equations, except now we're dealing with inequalities versus equations. The solution to a system of inequalities is represented by the overlap or the intersection of the two graphs. I think that'll become apparent when we start graphing some of these. The steps for solving or graphing a system of equations or inequalities. First thing we need to do is to put both inequalities in slope-intercept form if needed. Sometimes they're only going to be that way for you, other times we're going to have to do a little manipulation of the inequality. The second step is going to be to graph each inequality on the same coordinate plane. And I find it best if we usually shade it in two different colors. It makes the overlap or the intersection stand out a little better. And the final step is to just realize that the solution is the overlap. Okay, so the overlap of the two graphs is the solution set. Those are the solutions to your inequality. I'll give you a minute or two to go ahead and copy this down, and then we'll move on to a couple of examples. Here's our first example. We've got 2x plus y is greater than 1, and negative x plus y is less than or equal to 3. Now, neither of these are already in slope-intercept form, so let's go ahead and put them in the slope-intercept form. On this one, if we subtract 2x from both sides, the result is y is greater than negative 2x plus 1. We've got that one in slope-intercept form. Let's go ahead and put this one in slope-intercept form. We need to get the x to the other side so we can isolate y. So let's add x to both sides. When we do so, we've got y is less than or equal to x plus 3. So we've got them both in slope-intercept form, so let's go ahead and get the graphs in. This one has a y-intercept of 1, so we start out at positive 1. It has a slope of negative 2, which means we can go down 2 and 1 to the right, down 2, 1 to the right, and so on. Or we could have gone up 2 and 1 to the left, up 2 and 1 to the left. Since this is just a greater than sign, we need to use a dotted line for our boundary. So we're going to start at this point and we're going to draw our dotted boundary. Remember, the dotted boundary is just simply stating that the boundary itself is not part of our solution set. This one says that our solution is greater than that. So we're going to graph it on the greater than side. We can always check it if we plug in 0, 0 to see if this will make a true statement. If we put 0 here and 0 here, well, this would be negative 2 times 0, which is 0 plus 1. And so this is saying 0 is greater than 1, which is false. So we know we do not want to shade on this side. We want to shade on the greater than side. So let's go ahead and shade that in. We'll use a highlighter. And since we chose red on this one, we'll use red, highlighting red. And so we're going to bring this down and we're going to shade it all in. Okay. And let's go ahead and just fill that. Okay. So we've got that one graphed. Let's go ahead and take a look at the one we did in green here. On it, we've got y is less than or equal to x plus 3. Well, we have a y-intercept of positive 3, so 1, 2, 3. It's a little dark for me, okay. And then, let's see, we have a slope of positive 1. So let's go, since it's positive 1, and I've shade covered that in, it'll be easier to go down 1 and 1 to the left, down 1, 1 to the left, down 1, 1 to the left. Okay. You still end up with a positive slope. On this one, we have a boundary that is solid, okay, because it has the or equal to part. So I'm going to start here and I'm going to draw my line, and it's going to come up through here. So, and on this one, since it said that the solution the boundary is part of the solution. We use the solid line. This one says that the solution is less than or equal to that, so I'm gonna have to shade on the bottom side of the line. So I'm gonna shade it in with my green. So let's get a highlighter. Let me do it with highlighter this time. I think it'll work better. I'm just gonna use that color. Okay, so on this one, if we shade it in, you can see our overlap. I'll just go ahead and shade this in this time, and it'll be a little transparent this time, and we can see what we've got here. As you can see, that darkened area, that is our solution. That is the overlap of the two inequalities. Okay? So our solution, the ordered pairs that would be a solution to both of these inequalities fall into this shaded area. Okay? I hope that makes that first, when we were going over the rules, I hope that makes it a little bit clearer. Let's go ahead and take a look at the next one. This one, we've got 3x minus y is greater than or equal to 2, and we have 3x plus y is less than -5. Again, neither one of these are in slope-intercept form. Move this one down out of my, excuse me, that was a faux pas. Let's move this one down out of our way here. It will, it's not going to. All right, so, real long cut. Let's go ahead and subtract 3x from both sides. That leaves us with -y is greater than or equal to -3x plus 2. I can't have -y, so I'm going to multiply this by -1. When I do so, forgive me when I'm going to put this up on top, that changes the sign on everything through here, but it also, since it's an inequality, it's going to flip the inequality sign. So the result is y is greater than, or excuse me, less than or equal to 3x minus 2. So there's our first equation. Our second inequality, we need to subtract 3x from both sides again. When I do so, I'm left with y is less than -3x minus 5. So we've got our two inequalities. We've got them in slope-intercept. Let's go ahead and graph them. The first one is -2 is the y-intercept. Here's -2. The slope is a +3, which tells me to go up 3 and 1 to the right, up 3 and 1 to the right. I could also go down 3 and 1 to the left and still be positive. This one again has the or equal to part, which means we need to use a solid boundary. So we'll draw our boundary up through here using a solid line. Gotta get arrows on both ends or my class will never hear the end of it. So there's our boundary. This says that y is less than or equal to that, so we need to shade it on the lower side. So let's get that shaded, and let's use purple for that, and we'll go ahead and shade this in, and it's on the lower side. So we've got this shaded in. I'll go ahead and just use it with highlighter so we can see the lines this time. So bear with me here. Okay, so we've got that one graphed. If I wanted to check it, again, I could plug 0, 0 in. If I plug 0, 0 in, since it's not in the shaded area, it should not work. So 3 times 0 is 0, minus 2 is -2. This says 0 is less than or equal to -2. That's false. That's what we wanted because that's not part of our solution set. Our solution set is over here. Let's go ahead and graph the second one, which is y is less than -3x minus 5. Well, our y-intercept is -5, so we're going to come down to 1, 2, 3, 4, 5, -5. And our slope is a -3. Now I cannot go down 3, so I'm going to have to go up 3, 1, 2, 3, and 1 to the left. Up 3 and 1 to the left, up 3, 1, 2, 3, and 1 to the left. So there, on this one, we've got, it does not have the or equal to part, which means we need to use a dotted boundary. And so we start here and we go ahead and we draw our line. So we've got our boundary here and our boundary here. On this one, it says y is less than that, okay? Less than on this one happens to be on this side. We could check that with 0, 0, plug 0, 0 in. Over here, that would be negative 3 times 0, which is 0. Minus 5 would be negative 5. 0 is not less than negative 5. So we know we need to shade on this side. Let's go ahead and get our shading in. And as you can see, our solution set on this one, a part at least that shows on the graph, is a very small overlap down here. But what we need to remember is that's continues to go on and get wider as it goes. So our solution set is actually this part of overlap. So I could take any ordered pair that's in this overlapped area, and it should be a solution to our inequality. One last one. These two are unique examples, I guess, or they're not in slope-intercept form. Well, I guess the lower one is in slope-intercept form. But this one just says y is greater than negative 1. That means x. X is always going to be greater than negative 1. Doesn't matter what y is. So when we graph this one is just a vertical line, okay? And we know that it is, the y is always greater than negative 1. So our boundary is actually going to be negative 1. Doesn't matter what y is, our boundary is always negative 1. So we're going to go ahead and draw a vertical line. We do not have the or equal to part, so we need to use a dotted boundary. So our dotted boundary is actually going to be right here. And then we need to shade it in on the greater than side. Well, greater than on this time would be, it's going to be to the right, because that's where it's going to be greater than. So we're going to go ahead and shade this whole side in here. So bear with me as I try to get it shaded in. So you guys are going to have fun using the colored pencils today. All right, so we've got that shaded in. Now we need to go ahead and graph this one. This one says y is less than or equal to negative 3. That means it doesn't matter what x is, y is always going to be less than or equal to negative 3. Well, negative 3 is 1, 2, 3 down here. It says it's or equal to, so we know we're going to use a solid line as our boundary. So we're going to come down to 1, 2, 3, negative 3 on the y. We're going to go ahead and draw our boundary in. Okay. On this one, it says it's less than or equal to. Less than is below. So we'll go ahead and shade this in. And it's everything below that line is a solution. And as you can see, by the overlap of these two graphs, you can see where the solution set begins. So I could take any ordered pair that's in this shaded area. Actually, go down here and cover all that up too. Okay, and that would be part of our solution set. I hope that helps. Did you look over this? Have any questions? Be sure to ask.